Wavy curve method. This method is used to solve the inequalities in single variable. Okay. So in previous lecture we learned about the inequalities, how to represent the inequalities. An inequality is represented if we are having the expression as LHS and RHS side. If these expressions, in between these expression, if we use is greater than, less than, greater than or equals to, less than or equals to, then the expressions are called as inequalities. Okay. So now to solve the inequalities, these inequalities which are in single variable, we use as the wavy curve method. Okay. So we have seen that in the previous lectures and about the how to represent the intervals, when the we learned about open intervals, closed intervals, semi-open, semi-closed intervals, curl intervals, and we have seen some basic properties regarding the inequalities. Okay, now we are going to learn wavy curve method. So here I am considering one example. Okay, the example we are considering it as the inequality as x square minus 4x plus 3 greater than 0. So which is the inequality. Now to solve this inequality, this wavy curve method we need to follow, and it has some rules to solve this inequality. The first thing we need to check in this one is in the inequality, RHS of the inequality is made to 0. Okay, is made to 0. Now we need to make the inequality. Okay, now this is the LHS and which is as RHS. So we need to make the RHS of the inequality as 0. Here in the question it is directly given as 0. So no need to change the inequality. So if any quantity is given, move that to the LHS side and make this inequality as 0. Okay. So after making the inequality of the RHS is 0, now next rule we need to follow, the next step we need to follow, factorize the LHS. Okay, factorize the LHS. Okay, now how to factorize the LHS? Given that x square minus 4x plus 3, we can factorize this with what is x minus 1 into x minus 3. Okay, can we factorize or not? Yes. Okay, x minus 1 into x minus 3. So if we multiply these two factors, we will get as x square minus 4x plus 3. So after factorizing the given inequality, next we need to check for the coefficient of, okay, the coefficient of x. Okay, we need to check for the coefficient of x in every factor is plus 1. Okay, we need to check for the coefficient of x in every factor is plus 1. Okay, now here x minus 1, the factor having the x's coefficient as 1. In the factor x minus 3, again the x is having the coefficient as 1. Okay, so it is satisfying the third rule also. Next, we need to check for the powers of the factors. Okay, we have the factors and now we need to check for the powers of the factor. Now I am representing the power of a factor as p. Now if p is odd, the factor is an odd number. Okay, the factor is an odd number. Now change the sign has to be changed. Okay, sign has to be changed. Okay, now if the power is, what it is, even. Okay, if the power is even, no change in sign. Okay, no change in sign, which is the important consideration over here. Now after making the coefficient of x as 1, we need to check for the powers of the factors. If the powers of the factor is odd, okay, if the powers of the factor is odd, then next we need to change the sign. If the powers, what it is, of the factor is even, if the power of the factor is even, no change in the sign. Okay, right. Now if the inequality, now the rule 5 is, what is the rule 5? Now check for the inequality. So what is the inequality now? Okay, if the inequality is greater than, Okay, if the inequality is greater than, then we have to use the sign as plus. Okay, we have to use the sign as plus. Okay, so if the inequality is less than, we need to check for the sign for the negative. Okay, if the inequality is less than, we need to check for the sign of the, what it is, the range in the sign of the negative range. Okay, now either greater than or equals to, greater than or greater than or equals to, we need to check for the plus sign range. If it is less than or less than or equals to, we need to check for the negative sign range. And the next one is, if the inequality is less than or greater than is given. Okay, if the inequality is less than or greater than it is given, now we need to use the open braces, or the inequality has to be, that means that particular factor has to be represented with small circle. And if the inequality is greater than or equals to or less than or equals to, then we have to use the closed interval. That means the factor has to be represented with the dot. Okay, now here we need to here we check for the third rule. Okay, now what is the fourth rule? To verify the fourth rule, we need to draw a real scale. Okay, we need to draw a real scale. So which is from, the real scale is from minus infinity to plus infinity. Now we need to draw a real scale and represent the roots over here. So what is the values of x? If it is equals to 0, the values of x is 1 and 3. So let's consider 1 over here and 3 over here. Okay, 1 and 3 we are representing in real scale. Okay, so why? Because if x minus 1 is a factor, that means x is equals to 1. X minus 3 is a factor, that means x is equals to 3, or the values which satisfy the equation, but it is inequality. Now what it is here, the symbol. Now go for the and here we need to, first thing we need to consider the rightmost of the, okay, the rightmost of the scale has to be represented with plus sign. Okay, the rightmost of the scale always represented with plus sign. This is the important consideration over here. And now the inequality, go for the rule 5. If the inequality is greater than, okay, now what it is, and here x minus 1 and x minus 3, now here it is greater than. Greater than means the values are not included, then 3 has to be represented with small circle. Please watch the previous video, you can understand. If it is greater than, the values are not included, then we are representing with small circle. 1 and 3 are not in a solution. Okay, so now it is plus. Now what it is, now we are moving from the rightmost minus infinity to plus infinity. We are moving from minus infinity to plus infinity. Now here, so we are represented the rightmost of the root. Okay, rightmost of the root as a plus. Next, now we are moving from the minus plus infinity to, we moved up to the 3, value 3. So now check for the factor of the 3. What it is? X minus 3. The power, what is the power over here? X minus 3 power 1. So 1 is an odd. Okay, 1 is an odd number. Okay, 1 is an odd number. So if the factor's power is an odd, then we need to change the sign. Now up to 8 it is plus sign. Now we need to change the sign as minus. Okay, now from the 3, okay, from the 3 to it is 1, it is minus. Now we reach it to the 1. Okay, now we reach it to 1. So what is the x minus 1 factor power? The x minus 1 factor power is also 1. Again it is odd. After reaching the 1, the x minus 1 power is odd. So the power is odd. Again we need to change the sign. Now up to 8 it is minus. Now it has to be changed as plus. And there are no roots over here, though no values to be checked for. Now we can write x minus 1 into x minus 3 greater than 0. So for rightmost of the 3, rightmost of the larger root has to be represented with always as a plus sign. Now moving from the plus infinity to towards the minus infinity, we have the root at 3. Now at 3, Okay, at the value of 3, the power of this factor x minus 3 is odd. Then up to it we are having plus sign. Now we need to change the sign. And again moving towards the minus infinity. Now we obtain the value as x is equals to 1. After reaching this, the factor x minus 1 is having again the power as odd. Then again we need to change. If the power is odd, then we need to change the sign. Okay, now we can represent as in a scale as this is a positive curve, and over here 1 2 3 it is negative. And again this is the way of representing. Okay, this is the way of representing the given inequality. Now we have to know the intervals for this one. Okay, now the rule 5 came into existence. What is the inequality as given over here? Greater than 0. If the inequality is greater than 0, where we have to check for plus range. Okay, plus sign. Where we are having the plus sign, this is the region of plus sign. This is the region of plus sign, and this one is also region of plus sign. So greater than 0 means now the x includes these plus sign representations. So whenever we are having plus sign, the plus sign is having from minus infinity comma 1. Okay, minus infinity comma 1, and here it is greater than and less than, or greater than or equals to, less than or equals to. It is greater than only. The inequality is given as simply it is greater than only. So if it is greater than, how to use we as open braces? We have to use a open brace. So at the one we have to use a open brace, and minus infinity always represented with the open brace. Then next, another reason is 3 to infinity. Okay, 3 is also open brace. Why? Because the inequality is greater than only. Greater than means use the open braces, and infinity plus infinity is always with the open braces. Now the two regions, so minus infinity to 1 is a solution for x minus 1 into x minus 3 greater than 0. Similarly 3 to infinity is also solution. Now these has to be combined, the union. Now the union has to be given. That means now we obtain the solution of this inequality. Okay, the solution of this inequality, the x belongs to minus infinity to 1 open intervals union 3 to infinity open braces, which is the solution for the given inequality. I think now you understand how to solve the inequalities using the wavy curve method. Let me go for another example. Question is x minus 1 into x minus 2 into x minus 3 less than 0. Okay, so solve this inequality and asking for the solution of x, wherever what are the values of x which satisfies this inequality, which makes this inequality as a true statement. So for this one we are using the wavy curve method. So first thing what we have to check for, make the RHS of the given inequality is 0. So the rule 1 is satisfied. Okay, the RHS is 0. Next route is factorize the LHS. Okay, here the LHS question itself given in the factorization. X minus 1 is a factor, x minus 2 and x minus 3. The three factors are given. Now we factorize the LHS. Rule 2 is also satisfied. Okay, next check for the rule 3. Coefficient of x equals to plus 1 in every factor. Okay, coefficient of x is equals to plus 1 in every factor. The rule 3 is also satisfied. Now we need to represent the factors, the values. Okay, x is equals to 1, x is equals to 2, x is equals to 3 on linear scale. We represented the values of x 1 2 3 on real scale. Okay, so next what it is, now the inequality is given as less than. Less than means we have to use the open braces. Less than or greater than, the rule 6. Less than or greater than, we have to use the small circle. Greater than or equals to, less than or equals to, close circle. Here the inequality is given less than means now we need to represent with the small circles. Over here we represent as a small circle. So that means the values x is equals to 1, x is equals to 2, x is equals to 3 are not in solution, but in between values are in the solution. Now what it is next after this? Okay, rule 6 is over. Okay, we go further. Rule 6 is over. Next we need to check for the powers of the, okay, we need to check for the powers of the factors. So before that, the rightmost root, okay, to the right of the rightmost root, okay, right of the rightmost root, always remember this point, right of the rightmost root, okay. So rightmost root is 3, to the right, okay, to the right it is always represented with plus, always represent with plus, which is an important point. Right of the rightmost root always represented with plus sign, okay, always represented with plus sign, okay. Now it is represented, and we are moving from plus infinity to and reach towards the, what is root 3. So what is root of the x is 3. Okay, we reach towards the value of x as 3. So what is the power for the x factor? What it is 3 factor? What is x minus 3? The power is 1. So 1 means next we need to change the sign. If the power is odd, we need to change the sign, plus, and here it is minus. And from the 3 to we reaching towards the 2, okay, we reach towards the 2. So at x minus 2, the factor, this is having the power as again 1. So the next we need to change the sign, okay. Now minus changed to plus, okay, right. Next we are reaching towards the x is equals to 1. At this x is equals to 1, the factor x minus 1 is having again the power is 1. Then simply change the sign in the intervals. So from rightmost 3 to infinity plus, 2 to 3 minus, 1 to 2 it is plus, and minus infinity to 1 it is minus, okay, right. The rule 4 is also over, rule 4 is over, rule 6 is also we checked. And what is the rule 5? Now we need to check for the rule 5. The inequality, if it is greater than, the solution is in the range of plus sign. If it is less than, we need to check for the solution of negative sign. So here the inequality is negative, so that means what is our required solution? Now I am drawing over here, sorry, okay, it is negative, okay, it is negative. So it is positive, positive we are obtaining up to 3, and 2 to 3 negative, and again 2 to 1 positive, and again it is negative, okay. Our inequality is less than, less than means we need to check for the range where the negative sign is having, we need to check for the range where the negative sign is having. This is the negative sign, and which is also the negative sign. So that means now we can write the solution as, so the negative sign from where it is having minus infinity to 1, we can write as minus infinity to 1. Minus infinity is always open braces. Now what is the brace at 1? Yes, what is the brace at 1? It is less than symbol only, okay, it is less than symbol, we represent it with the small circle. Small circle is open interval, small circle represents the open interval, minus infinity to 1, and 2 to 3, 2 is an open interval, 3 is also an open interval, 2 to 3 again it is negative, 2 to 3 negative union. So these two ranges is our solution. Then we can write the solution of this inequality as x minus 1 into x minus 2 into x minus 3 less than 0 as minus infinity to 1 union 2 to 3. So now consider another question, x plus 1 whole power 3 into x minus 3 whole power 4 is less than 0. Okay, now we have to solve the solution for this one, the values of x where this inequality is less than 0, with this inequality is true statement. Okay, so what is the first thing? RHS of the inequality is made to 0, okay, that is satisfied. Factorize the LHS, LHS is factorized, okay. Coefficient of x is 1, okay, the coefficient of x is plus 1 only. Next we are having the values of x as x is equal, x minus 3 means x is equals to 3, and x plus 1 means x is equals to minus 1, okay. Now in a real scale of minus infinity to plus infinity, now represent the two values where x is equals to minus 1 and x is equals to plus 3, okay, x is equals to minus 1 and x is equals to plus 3. So now what it is, the right of the rightmost root is always represented with plus sign. So represent the right of the rightmost root. 3 is the rightmost root. It is represented with plus sign. And here the inequality is less than. Always the roots are not included. Less than means the roots are not included. Represent with open circle. Okay, right. So right of the rightmost root is represented with plus sign, and we are moving from the right to the left and we are reaching the 3. So the x minus 3 factor is having the power as 4. Power is even, so power is even, there is no change in sign, that means sign not changed, that means again it is plus. So up to yet we are having plus, again after reaching the 3 also we need to represent with plus, and we are reaching towards the minus 1. So x plus 1, minus 1 means the factor is x plus 1 power 3, which is odd. Okay, if the power is odd, then next we need to change the sign. Plus has to be changed to minus over here. Plus has to be changed to minus over here. That means here we'll obtain the, what it is, curve as in this manner. Okay, and next the fourth root is over. Now the inequality is greater than or less than. Inequality is less than. If it is less than, now we need to check the negative sign. Wherever we are having the negative range from minus infinity, this is the negative range of our required inequality. So this is the negative range. Negative sign range is minus infinity to 1. Okay, and it is less than means the open interval only. So we can write this as minus infinity to minus 1 open braces, which is nothing but x belongs to minus infinity to minus 1 is the solution for this given inequality. Okay, the next question is x plus 1 into x minus 3 whole square into x plus 4 less than or equals to 0. Okay, less than or equals to 0. Okay, now this is the inequality he has given. So directly the first rule, RHS of the inequality is 0 satisfied, the LHS is factorized satisfied, the coefficient in every term, the coefficient of x is plus 1 satisfied. Then next we need to represent in a linear scale, that means a real axis. What is minus infinity to plus infinity, the values of x are, so what we obtained is x plus 1 means x is equals to minus 1 is one thing, and x plus 3, x minus 3 equals to x is equals to plus 3 is one root, and x plus 4, x is equals to minus 4. Okay, x is equals to minus 4. Okay, x is equals to minus 4 is another. Okay, so which is from plus, what is plus infinity to minus infinity. Okay, right. Now next, the rightmost of the, okay, the right of the rightmost root. Okay, here, okay, right, here it is less than or equals to. If it is less than or equals to, we need to consider these root size in the solution. That means represent with closed, small closed circle, or represent with dots. Okay, these are to be in the solution, represent with dot. Okay, right. The right of the rightmost root, here 3 is the rightmost root. The right of the rightmost root is always represented with plus sign, and from the plus infinity to we are reaching the root 3. So if we are reaching the root 3, the factor, the x minus 3 is having power as 2. If it is power is 2, that means even. Power is even means there is no change in sign. Again next interval also it is plus only. Now we are reaching to minus 1. What is the factor? X plus 1. The power is 1. That means odd. The power is odd means we need to change the sign. In the next interval, plus changes to minus. Okay, plus changes to minus. Now we are reaching to minus 4. That means the factor is plus 4. Here what it is plus 4 means? The power is 1. X plus 4. The power is 1. Power is 1 means again we are changing the S. Again we are changing. It is to sign, minus changes to plus. Okay, these are the required intervals what we are obtaining. Okay, right, very good. Now here, what next thing is, after the fourth rule is over, we need to check for the inequality range, where the inequality should be considered over here. If we draw a curve, what we are obtaining, this is the range we are obtaining. Okay, this is the way of curve we are obtaining, but it is less than or equals to. Less than or equals to means, okay, greater than or equals to, less than or equals to, we need to check for the negative sign range. Where it is having the negative sign, this is the negative sign range. Okay, this is the negative sign range. Now what is the solution? -4 comma -1, but these are equals to, less than or equals to, so that means these are included in the solution. -4 comma -1 closed interval, and again we know that if it is less than or equals to, every root is in the solution. Okay, every root is in the solution. That means if we substitute x is equals to 3 equals to 0 equals to 0 0, that means it is a true statement. So here 3 also be included in the solution. Whenever we are having less than or equals to, every value of x has to be included in the solution. So that's why particular value of 3 is represented with curly braces. Okay, only 3 has to be included, means we need to represent with curly braces. So -4 to -1 union curly 3. So that means what it tells us? So it is in the having the range of -4 to -1. At -4 it is 0 equals to 0, -1 it is equals to 0, and in between -4 to -1 it satisfies the condition less than 0, and at 3, okay, at a value of x is equals to 3, and again it is equals to 0. This is the way of finding the solution of the inequalities. Okay, and here we have to discuss about the another rule, that is the rule 7. Okay, if the given inequality in a fractional form, that means a linear by linear or linear by quadratic, quadratic by linear, or what it is, quadratic by quadratic. So now I am considering one example, what is x minus 1 into x minus 2 by x minus 3 is greater than or equals to 0. Now if the given question inequality is in the form of some numerator by denominator, how to solve this type of inequalities? Okay, it is same, follows all the rules, but here we need to consider over here it is as the denominator factors. Okay, the denominator factors are not in the solution. Okay, the denominator factors are not in the solution. So that means the denominator factors are always represented with open brackets or open circle. Or are you getting? Open brackets. Okay, so the denominator factors are always represented with open brackets. So that means what it is, open braces. So here x is equals, denominator is having x minus 3 is a factor, that means x is equals to 3. If x is equals to 3, this inequality is not defined, so that's why those are not included in the solution. So the denominator's factors are not a part of solution, which is the important one. The denominator factors are not a part of the solution, always represented with small open circles. Okay, right. And how to solve this expression? Now we are having represent the factors on a real scale, that means from minus infinity to plus infinity. So what is x minus 1 means x is equals to 1, and x minus 2 means x is equals to 2, and x minus 3 means x is equals to 3. And over here, so x minus 1 greater than or equals to, so the numerator factors are included in the solution, so that means these are represented with dot, and x minus 2, this is also represented with dot, but x minus 3, it is in the denominator, the denominator factors are not in the solution, this is represented with open circle. Okay, this is represented with open circle, and we have the root, what it is, the right of the rightmost root. Here 3 is the rightmost root, is always represented with plus, and here all the factors are having power 1. So at every root, that means that every value of x, the sign has to be changed. Why? Because all are odd powers. So that means from plus infinity to 3, from 3 to 2, it has to be changed the sign. Why? Because power is 1. And again from 2 to 1, it has to change the sign, it is plus. And from 1 to infinity, minus infinity, it has to change the sign. This is the way of representing if any inequality is in the form of numerator by denominator. The denominator factors are not a part of the solution, not included in solution. Okay, that always the denominator factors are always represented with open braces. Now draw a curve over here. we are getting like this. Okay, we are getting like this. And what we have to represent, we need to check, for plus range greater than or equals to, means we need to check for the plus sign range where it is having the plus. Now from 1 to 2 it is in plus range, as well as from 3 to infinity also it is in plus range. Now we can write what it is, 1 comma 2. What are the braces back intervals we need to use here? 1 is included in the solution and 2 is also included in the solution. So 1 comma 2 open braces, and another one is 3 to infinity. Okay, 3 to infinity. Infinity is represented with open braces, but 3 is the denominator factor. It is not in the solution. It is also represented with open braces, and these two gives us the required solution, and use a union in between these two. Then x belongs to closed interval 1 comma 2 union open interval 3 to infinity. I think now you understand how to solve the inequalities using the wavy curve method. In the next lecture, we will solve few more problems to understand this method in very well. Okay, in an easy manner. Thank you. Thank you very much.